Hey guys, let me focus in here. This is our Thursday stuff. Kind of walk through this a little bit. A couple of new graphs today that you're going to see. So, stem plots are the new thing. What is the most important thing to remember? We're talking about labels. Labels is one of the most important things. And then a scale and a key. So we got to label it, and we got to label the scale and the key. So that's the biggest thing here. So if we just take the information that's given here, and you guys, we'll just take the males for right now. So I'm going to make a stem and leaf plot here. Whoops. I'll draw it a little bit bigger for you guys so you can see it. I'm going to make a T just like that. And I've got 154. 154 is my lowest, and my highest looks like 183. So I'm going to take it and I'm going to write the first two numbers, which is the stem. Oops, 18. And then the leaves are the numbers in the back. And it's better to do them in order so you can see them. So I'm going to go with 151. So I write this. So it'd be 151. And then my next one would be 154. Okay. And then my next one would be 157. You may miss some. That's why I always cross them off like this, 157. And then we do 159. And then we're done with the 150s. Then we're going to skip the 160, which will be 162. And that 162 is gone. And 163. I'm going to get to one thing, and then I'm going to go ahead and stop and show you a couple different ways. And then we're going to go to 165. Now, here's the deal. There's 165 twice, so you got to make sure you put two of them there. So notice that I put two 5s because I have two 165s. Okay? So, and let me finish out the 160s. So we've got the 167 and 169. Okay, so this is the basic building of a stem and leaf plot. Okay, so what that ends up doing this just starts to organize the data in a little better format than what you have here. So this is the stem, and this is the leaf. And so you don't even have to have the T up here. That's just a bad habit of mine. You can even leave that T off if you want. So it's basically this idea of the whole stem and leaf piece. So now, when you look at this, you have no idea what this actually is. So if you write a little scale here, you put height of students, height of 14-year-olds, height of 14-year-old males. And then below it, you just use your first example. 151 equals 151 centimeters, sorry. That's a tall person. Centimeters. 151 centimeters. So here is my scale with my stem and leaf, and then I'm looking at it going, okay, cool. So what does 151 mean? It means 151 means 151. That means that this means 162. So it's a way to organize your data so you can compare. A couple of different ways that you can write these things just so we can I'm going to give you two different ways here to write these things. So you can make a middle like this, and you can put the stem here. Again, I'll just do part of one, so you don't have to watch the whole thing. And then I'm going to put the males on this side, and I'm going to do 1, 4, 7, 9, 151, 154. Okay, and then we'll put the females on this side. And then I would put, there's a 52. So I'd put 152 here. And I would do a 153 and a 153. Okay. And I would do, what's the next one? 53, 53. Looks like 57. 57, 58, 58, 58, and then we got another 59. Okay, so you can split them if you want to compare. So right now you can see that there's more females in the 150 centimeter range than there are males in the 150 centimeter range. So you can compare the distributions that way. So if you finish it out, you'll be able to compare the distributions. Now, there's another way to write this. And if you notice, this is starting to get really, really big. And if you notice, the females have a lot in the 160s, a ton in the 160s. So when you get too much, there's another way to do it. And you can split the stems. So this is a side by side. Don't forget your scale if you were going to do something like that. And then I'm going to show you guys how to split the stem. And this will just, again, it's for organizing data. So what we talk about in split the stem, and I'm only going to show you the 160s. So actually, I'll show you the one. So we got 150s and 160s. So all I did here, guys, is I split it into two groups. So for the females, I would write 2, 3, 3 here, and then I'd write 5 and up here. 7, 8, 8, 8, 9. So it doesn't make as long of a trail. So if I go to the females for 60, it'd be 0, another 0, 61, 63, and I'm always marking these off as I use them. 64, and then 260, and then so I'm done there, and now I got 265s. So as you can see, like I said, it's 266s. It's just for organizing data a little bit better. So you would organize the data that way. And this is what they call by split the stem. So you can do it any way you'd wish. Just it's all for organizing. So you got the basic stem and leaf. Remember, these are the stem, these are the leaves. Make sure you do a scale and a key so we know what it means. Make sure you label things if you start doing split the stem, or label this as male. I would label this as male also. And then this is a side by side, so you can compare two pieces. And then this one here is a split the stem, where if there's too many leaves, you can split the stem into two. You can split it into three if you want, but it has to be consistent. So 15, 16, and 17 would have to be split also. And if there's not anything in there, you just leave it blank. So that's how you deal with stem and leaves. All right. So now here's our next one. We have what's called a histogram. And so how do you make a histogram? You take the maximum minus the minimum, and you divide that by the number of class widths. All right, so now the idea behind this is that you're gonna organize data. It's for quantitative, it's not for categorical, so this is for quantitative. This is for quantitative. And so the number of class widths, you're going to want to use anywhere between 5 to 8 classes. And I'll show you what those are here in a second. So we're going to use 5 to 8. I would use the book to make, to show, sorry. Or I should say to learn calculator. Calculator histograms. Okay, I would do use calculator histograms. All right, so here we go. So we need our maximum, minimum here, and then we need our class widths. So as we look at this, I'm going to just start by doing a dot plot so you guys can see this. And I may have to do it a little differently here. So I'm going to make a dot plot, and I'm going to start down at 95. And I'm going to go 100. I'm going to do a real quick one. 105. 110. I don't even want to do that's a little too easy of a scale. Let's go 98, 101, 104, 107. So this is points per game. This is an older one. There's a new list out there that I haven't put in the notes yet. So then we just go down the list. We got a dot at 98, a dot at 96.5, a dot at 96.9, a dot at 93, 93.2, 96, 96 again. So it's right here. 101, 106, and you just go along, and we're just putting dots on there. So I turn the video off, the scale. So this is all the points per game for all the different teams. And you can see they're really clustered over here on the left. And if I would have stretched this scale out, you would have been able to see that completely. But it doesn't give us a really good clue about what we're looking at. So I'm going to go ahead and I'm going to look for the lowest number here. I think it's 93.2. Let me see here. I may be a little off. So 93.2. So I'm gonna use 93. Again, it's a rough estimate here. So I know my minimum's around 93. So I'm using that formula max minus min. Let's look at my maximum. Maximum. 106.1. I thought there was a 107. Maybe I was wrong. Did I go past it? Yep, 106. So we'll just go with, since it's larger than 106, I'm going to go with 107. So we got a 107. And what is that? 13. 13. And I'm going to use 5 classes. So I'm going to do 13 divided by 5, which gives us about, 2.6. Gives us 2.6. This is my class width. Okay? So this is my class width. So I'm going to go ahead and I'm going to draw it on here just to make it show up a little bit differently. So my class width, so if I draw this, I come across, I'm going to start at my minimum. I'm going to go 93, and I'm going to add 2.6. So 2.6 plus 93 is 95.6. 95.6. Okay? And then I'm going to add 2.6 to that. And then I'm going to do it again. I'm going to do it again. And one last time. 1, 2, 3, 4, 5. That'll give me my 5 widths. Okay? All right. So remember, I'm adding 2.6. So go ahead and finish that up and add 2.6 to that. Okay, so we've got our scale set up here. 106 doesn't, so there'll be a 6th one. It'll be off to the right here, and I'll move my scale here in a minute. So now what you have to do is you have to go through and you have to find the actual number of teams in between each of these boundaries. So I need to look for teams between 93 and 95 is the idea that you're going to use, okay? So let's go ahead, and I'm going to go ahead and turn the camera off, and I will do it, and then we'll look at the scale when we're done. All right, guys. So when we're looking at this is what it ends up looking like. I'll show you this one over here. This one over, oops, I can't move the table. This one over here has a 2 in it right there, and I'll explain why. So all I did was I counted up the number of teams, and I scaled it to the side, and I label it. This is the number of teams. There's 5 teams, 10 teams. So this group between 93 and 95.6 points per game, there are 10 teams in between that. And if you notice, it starts to give us a little bit of a shape to this. So we can start using these histograms to decide shape. Tomorrow in class, we're going to go over how to use the calculator too. So make sure you're ready to go. And so between 95.6 and 98.2, there are 8 teams. So as you guys can see that. Now let's run over here to this one. There's nothing in between 103.4 and 106, but there is exactly a 106. So what do you do with the ones that land on the class boundaries? I move them into the next column and then be consistent. Some people move them into the class width before. The number one thing you have to do is just be consistent. So I always just use the one above it, because if it lands on 93, I'm going to use this one here. So that means if it lands on 95.6, I'm going this way with it. So if they land on the boundaries, I move them up into the next one. Remember, it's a rough estimation. So when we're looking at this here, oh, good, I get a little bit more room out of this one. When we're looking at this, now I can sketch my graph, and it's looking like it is skewed right a little bit. So that's kind of how we deal with those. Okay, so that's how you build a histogram. Let's talk about how a histogram is different than a bar chart. Well, number one, bar charts are for categorical, and they're separated. Remember, the bars are separated. So the bars are separated. Histogram is quantitative. It's quantitative, and it is continuous. That's the big keys. Continuous. Continuous. I don't even know if I spelled that right. It's spelling. We'll just do that with a question mark, and I'll do this like it's on a computer. There we go. All right, so continuous. I missed the U, I think. So that's the reason why that we would tackle that. So the reason that there's a difference. Now, the next question, and I erased it, and I'll bring it back. You guys have it, though, is, oops, my light's turned off. I love this place. All right, here we go. Get back over here. There's a difference between, why would we refer a relative frequency gram? Well, remember, relative means we're dealing with percentages, okay? So I'm going to do a little, you can look at the other ones, but I'm going to do a little bit different thing. Let's do this, and I'll draw this one here, and let's say this is GPAs, and I have, in our class, let's say we have number of students here, right? Number of students, and in that here's our GPAs. We have between, let's say 0 to 1, 1 to 2, 3 to 4, and then so on. Let's say ours looks like this. Let's just assume that it looks like this. Let's just assume it looks like that. And we're a number of students, so we got like 4, and then we got 8, and then we got 12 students, right? So 12 means nothing to us, right? But if I went to compare it to the school, let's say, here's the school numbers, and we just use the same thing, and the school numbers were there, and ours is going to be something like this, and then let's see here, yeah, something like that, right? So if it looks something like this, and we have 1 to 2, 3, and then 4. Let's say ours looks like that, but the numbers are different, and we're looking at here, and this is 500, 400, 300, 200, and then 100. These numbers, they're not comparable. They're not comparable at all. But if I turned around and I changed this to percentage and said, this is based on percent, because if this was 500 and this was 12, you can say, oh, the school does way better because there's 500 students between 3 and 4 point GPA, and there's only 12 in AP stats. But if we change it to percentages and I say, oh, well, 60% of the AP kids have 3 to 4, and then we just kind of, let's say 40 and then 20. If we work it that way, and this one, it's scaled at 30 and then 15 and then 0, something like that. So now all of a sudden, 60% of the AP kids have between a 3.3 and a 4.0, but 30% between a 3 and a 4.0. So it's easier to compare. So that's why we always try to use relative histograms. And so again, it's the number in the class width divided by the total. Remember, the number, the count in the width in the class, I should say, in the class divided by total. That's our relative frequency. So that's how you find the relative frequency of that one. All right. So here's the last piece of today. What will cause you to lose lots of points? Lots and lots of points? Labels. Make sure you do labels and scales, guys. Labels and scales on these. Have a good one. We'll talk to you later.